Welcome back, folks. So I just want to talk one more problem, and I know in the last video I think I said how to use logarithmic properties, and then that example did not rely on any log properties. This one will. So let's take a look at how to solve this one. And whenever you're solving logarithmic equations, my advice is to, if possible, combine the logs so that you only have to deal with one of them. As the case is here, we only have two. We have log base 4 of x squared minus 9 minus log base 4 of x plus 3 equal to 3. And so the property that we're going to rely on in this case is that when you have the log of a quotient, I'll say x over y, that's equal to, I should give myself more room here, the difference of the individual logs. So, oopsies, log base b of x over y is equal to, there you go, log base b of x minus log base b of y. Okay, so how does that help us here? Well, at this point we have this piece and we're just trying to go backwards now. So I could do that by doing this. Log base 4 of x squared minus 9 over x plus 3. That's equal to 3. Okay. At this point we have just 4 cubed. Oh, sorry. Once we have it in logarithmic form, if possible, it usually helps to get it into its exponential form. In this case, that will help because we don't have to deal with the log anymore. We have 64, which is 4 cubed, is equal to this, x squared minus 9 over x plus 3. Now we could go about solving this equation by multiplying left and right side by x plus 3. But one thing that does is that actually gets rid of the possibility you might be losing a solution that you might have had before. So actually, what we can do in this case is we can actually factor the numerator there, because this is really x minus 3, x plus 3. X plus 3. And what we can do is simplify this fraction. Now, let's go back to what I just said. We might lose solutions when we do this. And so this is only okay to do if x is not negative 3, because we can't divide by 0. It's what you would be, what you would be doing if you allowed this. And so we have to make sure that x is not negative 3. So before we do that, before we go further, let's actually check this. So our original equation, remember, is this. Log base 4, and I'm going to use the combined equation just because it's a little faster. This is totally fine. X plus 3 is equal to 3. If we plug in negative 3, you'll see that inside here, we're going to get actually 0 over 0, which is, again, indeterminate. And so we already know that in the original equation, x equals negative 3 is not in the domain of the equation at all. So we don't actually need to worry about it because it can never be that in the first place. So we're okay to keep going here. So now we're looking at this equation. 64 is equal to x minus 3. And just get x alone, so we'll get x is equal to 67. Right? So that's how you that's how you will solve these. Again, be careful when you're factoring or multiplying both sides or anything like this, because there's always the chance that you're losing a possible solution. But in this case, you're totally fine. Now, what if we didn't see that and we multiply it through? We could do that, and that's totally fine as well. So I will do that. So we're going to end up with 64x plus, let's see, 64 times 3 is 192, I believe, is equal to x squared minus 9. If we solve this, well, we're going to have a quadratic here, so I'm going to write it as 0 equals x squared minus 64x. Let's see, negative 9 minus 192 is negative 201. I'm going to guess this is factorable, so let's give me 1 second here. Oh, yeah, so it actually is factorable, 67 and 3. So this will factor into x minus 7, x plus 3. And therefore, our possible values, our possible solutions, excuse me, are 67, because that'll make that first factor equal to 0, and negative 3. But again, if we check in the original equation, negative 3 is not in the domain, it's extraneous. Extraneous solution. This has been a while, so I'll actually write this one out. Extraneous solution, and therefore it would not actually be an answer, and so our only solution is actually 67 here. Thanks for watching, and Just have a good day, folks.